Assalamu alaikum 8th chemistry students, how are you? I hope you all are fine. Welcome back with the last topic of chapter number 2, that is electronic configuration. The last topic is electronic configuration. In this video I will explain how electrons are arranged in various shells and subshells, or electrons are arranged in an atom by using Auf Bau principle. What is electronic configuration? It is the arrangement of electrons. It is the arrangement of electrons in subshells. It is called electronic configuration. The arrangement of electrons in subshells is called electronic configuration. What are subshells? To understand about the subshells, we have to take the concept of shells and then subshells. So let's discuss about the shells and subshells. According to Bohr's atomic theory, the electrons revolve. Electrons revolve around the nucleus in an atom in one of the circular paths, and these circular paths are called shells. They are also called as orbits. Each orbit has fixed energy, so it is also known as energy levels. So shells are also known as orbits and energy levels. Each shell is described by an n value, and the value of n is equal to 1, 2, 3, 4, 5, 6, 7 and so on. N value increases means by increasing the number of shell, the distance of electron from the nucleus and energy of shell will increases. As the shell will be more, then there will be more distance of electron and nucleus, and the energy of the shell will also increase. Means first shell has less energy, second shell has more energy as compared to first shell, third shell has more energy as compared to first two shells, and so on. How can we represent a shell? Shell is represented by capital alphabets K, L, M, N, O and so on. According to n value, when n is equal to 1, it is K shell. When n is equal to 2, it is L shell, and 3 for M shell, and if the value of n is 4, it means it is N shell. Accommodation of electrons in a shell by using formula 2n square. So, nucleus is having protons and neutrons. Around the nucleus, first shell is there. If n is equal to 1, it is K shell, and by applying the formula, we will get 2. It means in first shell, 2 electrons accommodated. In the second shell, value of n is 2, so it is L shell, and by applying the formula 2n square, we get 8. So the accommodation of electrons in L shell is 8. 8 electrons can be accommodated in L shell. Now third shell. If n is equal to 3, it is M shell, and it has a capacity, or it can accommodate 18 electrons in it. The next fourth shell, n is equal to 4, and it can accommodate 32 electrons. By using the formula, we can get it. So N shell is having 32 electrons. Okay, now we will discuss what are subshells. Okay students, shells are subdivided into subshells or sub-energy levels. As shells are known as energy levels, so subshells will also known as sub-energy levels. As subshells are the subdivision of shell, so shells are subdivided into subshells or sub-energy levels. Each subshell having an orbital which can accommodate just 2 electrons. Each orbital can accommodate 2 electrons. And the n value, number of shell, is placed before the symbol of subshell. Before the symbol of subshell, the n value will be plates.
So what are orbitals? It is the three-dimensional probability space around the nucleus of an atom where the possibility of finding the electron cloud is maximum. Types of orbitals: S orbital. S orbital is spherical in shape and is 1 in number. P orbitals are 3 in number, that are px, py and pz. D orbitals are 5 in number, that are dxy, dyz, dxz, dz square and dx square minus y square. F orbitals are 7 in number with a complex structure. Relation between orbit, suborbit and the orbital. In simple words, we can say that this will give us the complete address of the electron. For example, if we want to find out the address of the Mr. X, then we must know about the city in which he lives, his colony and the house number to reach at the specific place. Similarly, if we want to find out the address of the electron, we must know about the shell in which the electron is, about the subshell and also the orbital of the electron to reach at the place of the electron.
What is electronic configuration? It is the distribution of electrons in subshells of an atom. It is distribution of electrons among the different subshells of an atom. How these electrons are distributed in different subshells. For this purpose, we use Auf Bau principle. Auf Bau principle stated that electrons fill the lowest energy subshell. Electron fills the lowest energy subshell that is available first. Let's see how.
At the Aufbau principle. The Aufbau principle, meaning building up, is used to determine the electronic configuration of an atom or ion. According to the Aufbau principle, electrons fill lower energy orbitals first. Here you can see the energies of the atomic orbitals, starting with the lowest energy, that's the 1s atomic orbital. Then we have the 2s atomic orbital, then the 2p, which are degenerate orbitals, which means they all have the same energy. Then moving on to the 3s orbital, then the 3p orbitals, which are degenerate orbitals, all have the same energy. Then next is the 4s orbital, which is lower energy than the 3d orbitals. On the right here, we have the order of filling of the atomic orbitals according to the Aufbau principle, which is lowest energy first. So we start by filling the 1s atomic orbital, then we fill the 2s orbital, then the 2p, then the 3s, then on to the 3p, and then the 4s orbital. Another 4s orbital fills before the 3d orbitals, because as you can see here, the 4s orbital is lower energy than the 3d orbitals. And after the 3d orbitals are full, we start filling the 4p, then we move on to the 5s, then the 4d, then the 5p, then the 4f, then the 5d, and finally the 5f orbitals.
Okay students, now the increasing order of energy of the subshells according to Auf Bau principle is here. 1s is having less energy as compared to 2s orbital, and 2s orbital is having less energy as compared to 2p orbitals. In the same way, 3s orbital is having more energy as compared to 1s, 2s, 2p and so on. Let's discuss some examples. How to do electronic configuration by using Auf Bau principle. First atom is beryllium, 9,4. Atomic number is 4, so it has same number of proton according to atomic number. 4 and number of electrons are equal in an atom. So electronic configuration will be of electrons, which are 4. Let's start the electronic configuration. First we will see the electronic configuration in shell. First shell, K shell, will accommodate 2 electrons because it can accommodate just 2 electrons. Now how many electrons are left? 2 electrons are left, so they will go in the second shell, that is L shell. So it is the electronic configuration of beryllium in shell. Now we will see in subshell. According to Auf Bau principle, you can use this Auf Bau principle diagram, or you can also learn this sequence to arrange the electrons in subshells. Okay, first 1s. S can accommodate 2 electrons, so 2 will come over here. Then 2s. It can also accommodate 2 electrons, so 2. How many electrons are there? 4. So 1s2, 2s2 is the electronic configuration of beryllium. If you see the structure of beryllium, in first shell 2 electrons, and second shell there are 2 electrons. Let's see the electronic configuration of silicon. Atomic number is 14, so it has number of protons 14 and number of electrons also 14. Electronic configuration in a shell. K shell will accommodate 2 electrons. L shell can accommodate 8 electrons. 8 plus 2 is equal to, yes, 10. How many electrons are left? 4 electrons are left. The third shell, M shell, has a capacity of 18 electrons. It can accommodate 18 electrons. So the remaining 4 electrons will come in M shell. Let's see the electronic configuration of silicon in subshell. We can use same the sequence or the diagram. Okay, 1s. 2 electrons will come here. Then 2s. Also 2 electrons can come. 4 electrons are accommodated. Now 2p. It can accommodate 6 electrons. Now there are total 10 electrons are accommodated. 4 electrons are left. Next is 3s. Can I write 4 with s? No, because S subshell can accommodate 2 electrons. So 3s 2. The remaining 2 electrons will go in next one, that is 3p. 3p will get 2 electrons. So the electronic configuration of silicon is 1s2, 2s2, 2p6, 3s2 and 3p2. If we see the structure of silicon, first shell is having 2 electrons, second shell is having 8 electrons and third shell is having 4 electrons. Now we will see the electronic configuration of ion. For the sodium ion, how sodium ion is formed? Sodium ion is formed by losing 1 electron. It will get positive charge, Na+. The atomic number of sodium atom is 11. So it has 11 number of electrons. But we are dealing with the sodium ion. So electrons in sodium ion will be 11 minus 1. Minus 1 why? Because it loses 1 electron. So now it has 10 electrons. So we will do the electronic configuration of 10 electrons, not the 11. Because sodium ion has 10 electrons. Okay, let's see the electronic configuration. In shell, K shell will accommodate 2 electrons and L shell will accommodate 8 electrons. Total 10 electrons are there which are accommodated in 2 shells. Now in subshells, 1s. How many electrons will be here? 2. So 1s, 2. Then 2s, 2. 4 electrons are accommodated. How many electrons are left? 6. Can I write with 2p6? Yes, because p subshell can accommodate 6 electrons. So it is the complete electronic configuration of sodium ion. Sodium ion is formed by losing the 1 electron. Okay, if we see its structure, you can see here sodium ion is having first shell 2 electrons and second shell with 8 electrons, and sodium plus in the center because there is 1 extra proton and 1 less electron. Next one is a chloride ion. How chloride ion is formed? It is formed by gaining 1 electron. The atomic number of chlorine atom is 17, so it has 17 electrons. But when it will get the electron, it will become 18. So electron in chloride ion is equal to 17 plus 1. Plus 1 means electron is added. So these are 18 electrons. So we will go for the 18 electrons. Electronic configuration of chloride ion in shell, it will be K shell will accommodate 2 electrons, L shell will accommodate 8 electrons, 10 electrons are there. Now how many electrons are left? Yes, 8 electrons are left, that will go in M shell. Although M shell can accommodate 18 electrons, but we have just 8 electrons remaining, so these 8 electrons will go in M shell. Electronic configuration in subshell by using the sequence or by using the Aufbau rule diagram or Aufbau principle diagram. In subshell 1s2, 2s2, 2p6. Total 10 electrons are there. Now 3s. How many electrons are left? 8 electrons are left. S can accommodate 2 electrons. So these are now 12. Then 3p. How many electrons are left? Yes, 6 electrons are left and they can come in p orbitals or p subshell. So 1s2, 2s2, 2p6, 3s2 and 3p6. It is the electronic configuration of chloride ion. See the structure? This one electron with different color is showing this electron is added from the other, or it is gained by a chlorine atom. That's why it gets the chloride or negative charge on it, chloride ion. It has one less proton. Okay students, it was the last topic, electronic configuration of second chapter. Let's summarize the chapter number 2, structure of atoms. In 1911, Rutherford performed the experiment, gold foil experiment, and proposed a planetary model that was rejected due to some defects. In 1913, Niels Bohr proposed a model for an atom that was consistent with Rutherford's atomic model. After that, we had discussed the isotopes and isotopes of different elements like hydrogen, carbon, chlorine and uranium. After that, we had discussed the uses of isotopes in different fields. And at the end, we had discussed the accommodation of electron or distribution of electrons in different shells and subshells. I hope you understand the chapter well. Thank you.